Hello, and welcome to today's European SharePoint, Office 365 and Azure Community webinar. My name is Laura, and I'm delighted to be joined by Patrick Koch, Senior Integration Engineer Software, AVL List, who will present the topic Azure and Infrastructure as Code, provisioning of Kubernetes cluster with an attached container registry and deployment of a workload. Remember to join in on the conversation about today's webinar on Twitter. Our Twitter handle is @EuropeanSP and our hashtag is #ESPC23. Don't forget to check out the Resource Centre. This is updated daily with the latest blogs, ebooks, webinars and how-to videos. Simply visit sharepointeurope.com and click the Content tab at the top. Continue your learning by joining us for our next webinar, Enable Everyone to Innovate with Low Code, which takes place on the 23rd January from 11 a.m. to 12 p.m. CET. For full details, please check out sharepointeurope.com/Power Platform Week. Last November, over 2,000 SharePoint, Office 365 and Azure professionals joined us in Copenhagen for ESPC 22. We now have an amazing showreel video full of ESPC 22 highlights. Visit sharepointeurope.com to watch this brief recap of all the learning, development, networking and fun that was had over this amazing 4-day event. The European Power Platform Conference 2023 is coming to Dublin. Join us from the 20th to the 22nd of June this year to power up your knowledge and connections. Book now at sharepointeurope.com/European Power Platform Conference. Microsoft Power Platform Week begins on the 23rd of January and runs right up until the 27th of January. Don't miss out on 1 week of free online Microsoft Power Platform learning. Visit sharepointeurope.com/Power Platform Week to find out more about Microsoft Power Platform learning opportunities. After the webinar, we will have a questions and answers session. Type any question you have in the questions window. Questions will be selected and answered at the end of the presentation. This webinar will be recorded and added to the Resource Centre, where you will be notified by email when it is available. And now I'm going to pass you over to Patrick, our webinar presenter. Hello, Patrick.
Hello. Thank you for the introduction.
And thanks for joining us today, Patrick.
I'm glad to be here. All right. Hey, everyone. Again, thanks for the introduction, Laura. I'm going to share my screen. Okay. Can you just give me a short feedback whether you can see my browser, including the Azure portal?
Yes, we can see that.
Okay.
Your browser with Azure portal.
Thank you, Laura. All right. What's the plan for today? In this session, I would like to show you how to create an Azure Kubernetes cluster and an attached container registry using Terraform. And to show something more fancy afterwards, according to how to work with it, I also would like to deploy a container workload using the Azure CLI. So here currently you can see the Microsoft Azure portal, which can be used for provisioning different services, among others, the Kubernetes cluster, virtual machines, etc. So currently, just to prove, there are no instances with regard to a Kubernetes cluster provisioned, and also at the container registry, there are no current services created. But I would like to change that, and I would like to do that with Terraform. So what do I need as a prerequisite for doing that? At first, I would need the Azure CLI. and of course, Terraform. So I will do all the stuff in Visual Studio Code. It's quite comfortable to work with. And yeah, if there are any questions, feel free to ask at any time. So don't hesitate if there are questions. Okay, so where to start? If you would like to use Terraform, then you create a so-called Terraform configuration file in which you define all the resources which you would like to provision in Azure. How does that look like? If you would like to do the very same stuff which I do, you can download the sample code from my GitHub profile. So that would be my GitHub profile. And here at repositories, I will grab Terraform _AKS minus ACR for Azure Kubernetes Service minus Azure Container Registry. So I'm going to clone the repository to get the Terraform configuration file on my local desktop. So let's check the URL, go back to Visual Studio Code. So I'm working on a development container at which I've installed all the necessary prerequisites, so the Azure CLI, Terraform, and further tools. So inside the container, I will create a new directory. I will name it Terraform. I switch to the created directory, and now I'm going to clone my repository. Right. So now I got a new directory, Terraform minus _AKS minus ACR. Let's switch to that. And inside this directory, I got now two .tf files, so two Terraform files. And I'm going to use that one. So therefore, I will simply remove the second one so that there will be no confusion. So currently inside this directory, there's just one Terraform file. Let's open that. So it's inside root, it's inside Terraform, and it's inside the directory Terraform _AKS minus ACR. And there we also can see the Terraform icon. And I'm going to open the file patricks -AKS -ACR.tf. And that's my Terraform configuration, which I'm going to apply against Azure to create the services which I would like to have. So the Kubernetes cluster, the container registry, and there are also further resources. But let's go through them step by step. So this configuration file contains of several blocks. The very first one is the so-called Terraform block, which also includes the provider. In our case, we would like to create the resources in Azure. Therefore, our provider would be the Azure Resource Manager. By default, the Terraform registry is used for that. So here at the Terraform registry, you can browse through the provider. And in our case, it's of course Azure. So that would be the official provider. And by applying this Terraform configuration file, a plugin is getting downloaded, and by downloading the plugin, you can use the revealed API of the Azure RM provider to create the resources which you would like to create. And here for this session, we would like to create, among others, here starting with line 24 to 29, a container registry, which manages container images. So this container registry is getting named Patrick's blog. In addition, so if you would like to create a container registry or virtual machine or some further services, you always need a so-called resource group. So a resource group could contain several other services, like here in that case, the container registry and the Kubernetes cluster. The resource group is named Patrick's blog, ACR AKS, underline resource group, and the location would be Germany West Central. As I'm from Austria, it would be quite good for me. So I stick here to the Germany West Central data center. So starting again, it's the Terraform block, which contains the provider. It's the provider block. We will have as a resource the resource group, which contains the container registry and the Kubernetes cluster. As you can see, there are always assignments here at the container registry and the Kubernetes cluster with regard to the resource group. And here, starting with 24 to 29, we have the container registry, which I'm going to push after the creation a container image to work with it afterwards. And starting with line 31 to 50, there we have the Kubernetes cluster. The Kubernetes cluster gets the name Patrick's minus AKS. I just create the default node pool. So after the Kubernetes cluster is getting created, there will be one node inside which we can use for getting the workloads run. And as a last resource, we have the Azure RM role assignment. What's the purpose of that? So if you are creating the Kubernetes cluster and if you're creating a container registry, you have to ensure that the Kubernetes cluster is capable of pulling images from the container registry. So without that role assignment, which you can see here, starting at line 52 to 57, the Kubernetes cluster, simply couldn't pull a container image. So to get a container workload run. So as a short recap, we have a Terraform configuration file, in which you define all the resources which you would like to provision. It starts always with a Terraform block, and after that, you simply define the resources which you would like to have. So it's a .tf file. The good thing is that you can easily version it, for instance, in a Git repository. Another advantage would be if you would like to use Terraform, that the resources which you provision and which you destroy are created in a repeatable way. It's rather easy to create and destroy them, so you can simply create them when you really need them, and you destroy it when you don't need it anymore, and you can save costs. Furthermore, you can automate it. For instance, you can put all the stuff into, for instance, an Azure DevOps pipeline, which would provision and destroy it also in an automated way. But let's now check how does it work in a manual way. For that, I would like to show you 3 Terraform commands. So the very first one, sorry for that, just before you conduct the Terraform commands, ensure, so in that case, that you are in the directory of the Terraform configuration file. And after that, start with Terraform init. So that would be the initialization command, which establishes a connection to the backend and which downloads the plugin. And by using the plugin, you can use the APIs to create and to destroy and to change the resources. As you can see, that's worked. Terraform has been successfully initialized. If we check now the files, as you can see, further files were now added. And if that worked, the next comment, which is worth to talk about, would be Terraform validate. So this command, as the name says, it validates the configuration. We get as a return that, the configuration seems to be valid. That's good. And now the next thing is, which triggers the real action, the final Terraform apply. So after conducting that command, all the resources which are specified in the Terraform configuration file are really getting created in your Azure subscription. So in our case, we have 4 resources. So it's the resource group, it's the container registry, it's the Kubernetes cluster, and the role assignment. So we could now already type enter to confirm it. After that, you would get the question whether you really want to provision all the stuff which you have configured. Then you have to confirm it by tapping yes. But if you don't want to do that, so if you are quite sure that you really would like to create all the stuff which you specified in the configuration file, simply type -auto -approve. And this conducts now the real provisioning. So we are now really trying to create a Kubernetes cluster, a container registry on Azure. As you can see, we are planning to add 4 resources. So you'll get some kind of overview about all the stuff which is getting provisioned. And now the magic starts. So this takes now approximately 4 minutes. Therefore, in the meantime, I can show you something different. So I told you that after provisioning the Kubernetes cluster and the container registry, we would like to see some kind of action by applying a container workload against the Kubernetes cluster. And for that, I would like to show you a simple container, a Linux container, which I've prepared. Docker run. Hi, I am your Linux container. So that guy here, so this container, which you can see here, which I've now run, that's the container which I would like to also run at the Kubernetes cluster, which is now getting provisioned. So it's a very simple Linux container, which just just prints, "Hi, I'm your Linux container," and which will terminate after a few minutes. So it's just for demonstration, of course, but I think it's working quite well for that example. So let's see what Terraform is doing. So here in the logs, you can see what's currently going on. So currently, the Kubernetes cluster is still creating. So starting with 20 seconds, so 1 minute, 50 seconds. Maybe let's risk it and go to the Azure portal, go to Kubernetes Service, and as you can see, Patrick's AKS is already there. But as you can see here in the status, it's currently creating, so we can't use it at the moment. Therefore, let's give Terraform again a few minutes to complete the provisioning of the resources. But in general, it's really fast. So before I've used Terraform, I couldn't imagine that a Kubernetes cluster is getting created that fast. If you've created a Kubernetes cluster, for instance, in Azure in a manual way, I think at least the clicking through the tabs will take more than 4 minutes, despite if you already know which values you have to enter in the input fields. So now we had 3 minutes, so probably 1 more minute to get it done. Maybe let's go back to the Azure portal and check the container registry. And there, as you can see, also Patrick's blog is getting created. And of course, it will be a blank container registry, so no container image is available there to getting managed or to derive a running container out of it. Let's again switch back to the Kubernetes cluster and succeeded. So the Kubernetes cluster is ready. The last thing which is now getting created is the role assignment, and now we are done. So it was rather fast, less than 4 minutes when I'm right. So we created now 4 resources: the Kubernetes cluster, the container registry, the role assignment, and the resource group. So now we are ready to start with the next thing, to deploy a container workload on the Kubernetes cluster. But maybe let's check again the resources. So the container registry, we have Patrick's blog without any container image on it. And we have the Kubernetes cluster named Patrick's AKS. So let's check the node pools. So there should be just one Linux node. Yes, so as you can see, we have the default node pool. There inside, there is just one node, which is available for getting workloads run and hosted. Maybe let's check also the workloads. So we get the default ones at the deployments, and in a few minutes, I would like to create a workload from type job. So currently there are no workloads available. Of course, we simply provisioned a rather new Kubernetes cluster on Azure. But of course, there's some work left. So what do we need for creating a container workload at the Kubernetes cluster. Of course, a container image at the container registry, which is attached to the Kubernetes cluster, would be fine. And I've told you that there are no container images on it. Therefore, let's change that. How can I do that? I simply go here to access keys. I'm going to enable the admin user, which provides me a username and some passwords and the login server. And by using those credentials, I'm going to push the container which I've shown you before. So how does it work? I'm going to type. So at first, I have to log in to the container registry using the login server. Therefore, I type docker login using the login server, patricksblog.azurecr.io. So docker login with the login server. Yes, so he's requesting the username for Patrick's blog, which will be Patrick's blog. And as a password, sorry, I have to copy that. As a password, enter that one. Again, Patrick's blog. It's not that easy. Now it worked. Okay. So now I'm logged in to the container registry and I'm ready to push the container which I've run before. Therefore, I will use docker push. And it's getting named. So patricksblog.azurecr.io. So the full name, respectively, the login server. Sorry. Now I'm back. Yeah, I will simply name the repo and as a tag Patrick's test container. Let's go for it. Pushing. Should be quite fast as the Linux container image is not that big. And this provides me the first container image on the container registry. Okay, should have worked. Let's check it. Repositories. And as you can see, repo is now created. And there we have Patrick's test container. When you click on it, you can see the full docker pull command if you would like to fetch it. So in my case, it wouldn't make sense, of course. Yeah, so now we have the container image at the container registry. So we could deploy it at the Kubernetes cluster. And for applying the workload, you would have two options. So at first go to workloads. The workload which I would like to create is from type job. So either you check, for instance here, apply a YAML in which you can insert the YAML code which describes your workload. But I would like, maybe I can show it to you. So I just grab an example. So it would look like that. So the good thing by using this editor would be that it would tell you if it is a valid YAML or not. But yeah, the bad thing is you have to click at too many buttons if you don't like that. But that would be the workload which I would like to create on the Kubernetes cluster. So as you can see, we have a workload from type job. The workload will have the name Patrick's test container, the very same name as the container. And as you can see, that's the image, the name of the image, which I have pushed before to the container registry to work with. So that would be option one. If you would like, if you click on add, then this workload would appear here at the workload jobs section. But I would like to do that with the Azure CLI. What do I need for that? Let's switch back to the Visual Studio Code. Let's maximize that. So I would like to deploy the workload using kubectl. Sorry if I told that wrong. So I would like to, I need the Azure CLI to update my kubeconfig. So the workload is getting applied by using kubectl. But if you type kubectl config get context, you can see there is no cluster available, no context. This is because the current kubeconfig file doesn't know anything about the Kubernetes cluster, which I've provisioned a few minutes before. And therefore, I have to update my kubeconfig file with the credentials of the Kubernetes cluster. And for that, I'm going to use the Azure CLI by simply typing a command. And this command will be that. So it's AZ AKS get credentials -- name, so the name of the Kubernetes cluster, which is Patrick's -AKS. And you have also to provide the resource group, which is named Patrick's block ACR AKS RG. As you can see, the kubeconfig is now getting updated. And if I run again, the kubectl config get contacts, then as you can see, now Patrick's AKS or the Kubernetes cluster is now included. And by using kubectl, I would like to deploy the workload. So again, the workload can be seen here, a simple YAML file, which defines here the name of the workload, the name of the container. It refers to the image of the attached container registry. So I'm going to simply create a new file on my development container, file, new text file. I'm going to insert the YAML code here, and I will save it in the same directory as I've saved the Terraform configuration file. And I will name the workload my workload. So now also my workload was created inside the directory. Let's switch back to the Azure portal. Currently, there is no job available here, but this will change now. So I switch back to Visual Studio Code. And now I'm typing kubectl apply -f my workload YAML. Enter. Now you can see that job batch Patrick's test container was created. Let's verify that, refresh it, and as you can see, a workload named Patrick's test container is running. What happens behind? The container image has to be pulled, and if the pull is done, the container can be hosted. So inside or in the workload, after the workload level, you get the container pod, the Kubernetes pod, sorry, which also is named Patrick's test container minus with appendix. And if you click on the Kubernetes pod, then you come to the container, which was defined to be named Patrick's test container. And now the container is running at the Kubernetes cluster. Let's verify it with kubectl in addition. Kubectl get pods. And as you can see, also Patrick's test container minus GTN76. So some arbitrary appendix for the Kubernetes pod is running currently for 67 seconds, 85. And if you would like, you could also attach to it using kubectl exec, name of it, dash, and we're now attached to the Kubernetes pod. Who am I? Oh. All right. So now also the container, the workload is deployed at a freshly provisioned Kubernetes cluster. Now we got as a feedback command terminated with exit code 137. So this simply means that the workload is now completed. Let's verify that. So currently that's now not refreshed. So from state running, it goes to state completed. So no workload is now running from type job is running on the Kubernetes cluster anymore. And that's how to deploy a workload against a quite new, fresh provisioned Kubernetes cluster. So as a short recap, by using a Terraform configuration file, in that case, that guy here, you can provision the resources which you would like to have in an automated way, in a repeatable way, using an infrastructure as a code approach. In my example, the Terraform configuration file contains of 4 resources. So it's about the resource group. It's the container registry, which manages the container images, which I would like to use afterwards for the Kubernetes cluster. Of course, the containers have to be derived by applying a workload. The next resource would be the Kubernetes cluster, and to be sure that the Kubernetes cluster is allowed to pull images from the container registry. Also ensure that you have a proper role assignment. If you would like, you can grab this example here from my GitHub profile. So again, so that would be my GitHub profile, github.com, Pat Koch. And here at repositories, simply go to Terraform _AKS -ACR. And Here inside of that, you have two examples of them. So we have used that guy here without the backend. The backend simply means that some further thing is getting created in addition to simply ensure that the state of the Terraform configuration is transferred to Azure and is not available on a local client. So by applying the configuration, you get here at the Azure portal the container registry. You get the Kubernetes cluster. You can, furthermore, to see something in action, push container images to the container registry. And after that, simply apply a workload against the Kubernetes cluster to run some workloads. And if you don't need, if you don't need anything or of your resources anymore, simply destroy it by using Terraform destroy. Click on enter. So now all resources which have been provisioned are now getting destroyed. So now I didn't use the -auto approve to show the other version to you. So if I just enter Terraform destroy, I will get some logs. And finally, the question whether I really would like to destroy all the resources. As you can see, I get some kind of overview. So the resource group is getting destroyed. The role assignment is getting destroyed. The Kubernetes cluster, the container registry. So again, the 4 resources which have been provisioned before are now getting destroyed. So the plan is 0 to add, 0 to change, but 4 to destroy. And now I'm going to confirm that with yes. And this will remove all the resources in my Azure subscription. This means also no costs are getting allocated, of course. And that's it. So as you can see, it's really amazing how fast you can provision resources by using Terraform on Azure in a repeatable, in a smooth way. And imagine if you would like, I think I mentioned it also before, if you would like to fully automate your provisioning and the destruction of your resources, you could also simply version your Terraform configuration, for instance, in Git, and use a Azure DevOps pipeline, for instance, which checks out the Git repository, which includes this Terraform configuration, and use dedicated Terraform tasks simply to provision and to destroy the resources. So this again takes a while. So all the stuff which I've created is now getting destroyed. I think according to the time, this also fits if there are some questions. Maybe we have some minutes more. But yeah, I hope this session was meaningful to you. I hope you enjoyed it. I hope you could see something new, that you got a benefit. And now I'm open to questions, and maybe I hand over back to Laura. So I'm looking
Thanks,
forward
Patrick.
to questions. No hesitations, please.
Yeah, thanks a million, Patrick, for a great presentation and demo. It was really informative. So we just have a couple of questions in here. So the first one I can see is, can the resources be provisioned with a pipeline too?
Yes, they can. So for instance, if we stick to the Microsoft technology, so to Azure DevOps, I think there exists dedicated tasks for the Azure DevOps pipeline with regards to Terraform. So Terraform task in which you can simply choose which action you would like to have. So is it the applying is it the provisioning part, or is it the destruction part? So yes, it's possible.
Brilliant. Thanks, Patrick. And there's just another couple of questions here. So the next one is, how expensive is it to host an Azure Kubernetes service in Azure?
That's hard to answer, but let's try it. So if I would like to start some calculations, there exists the official pricing calculator for an estimation. So simply type Azure pricing calculator, and here simply check Azure Kubernetes service. And here you can adapt the parameters as you would like to have it. So whether you just need Linux containers, or you also need Windows containers, for instance, how many virtual machines, so how many nodes you would like to have. So it really depends which performance you would like to have. Also here, according to the instances. But here, for instance, that example shows that you have approximately $85 per month. Of course, the more virtual machines you would have, then of course you have an increase of costs. But simply try it, for instance, with the pricing calculator, but also monitor it in the Azure subscription. So I think that guy here, so that the 170, for instance, here in that case, really just an estimation. Ensure that if you provisioned a resource, simply try to monitor it as often as you can, and maybe try to create some alerts. If you get over a specific threshold, that should be recommended. Yeah.
Brilliant. Thanks, Patrick. And there's just one more question here, but before I ask the question, I'll just state that if anyone else has a question they'd like to ask, please type it into the question window now and Patrick will answer it. So the last question I have here is, can I run Windows container workloads as well?
Yes, this works too. In that case, if we again check the Terraform configuration file, so by default, just Linux nodes are getting created here, that part, but you can also add a Windows node pool, and this would be the prerequisite to also run Windows container workloads. Therefore, in that case, here at line 12, you would have Windows instead of Linux.
Brilliant. Thanks a million, Patrick. So there doesn't seem to be any more questions coming in. So what we might do is wrap up the questions. So I just want to say on behalf of the ESPC community, thank you so much, Patrick, for taking the time today to complete this webinar. We really do appreciate it.
Thank you too. Glad to be here.
So this is the end of today's webinar. You can find this webinar and more at sharepointeurope.com/resource center. Thank you for joining us today. Take care and goodbye.